Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So, in the discussion of the property of the triangle centers, I left one about the in-center and orthocenter distance square, right? IH square equals to 4r square minus a to the power 3 plus b to the power 3 plus c to the power 3 plus abc divided by a plus b plus c. I proved this one. But I said for the second part, I didn't find an elegant solution. So thanks for the audience, Andy. I think he find a very elegant solution here to prove that IH square, or basically this one equals to this one. And with his permission that I'm going to share his idea of this proof to other audience. Okay, so the key point here is that how can we transfer this term to this term, right? If you look at here, we have 4r squared times cosine A, cosine B, cosine C. And we already know that for each edge of the triangle, we can represent it as 2r sine A, 2r sine B. And for this, AB is 2r sine C. So, but here we only have it like power term as 2, right? So that means we need to bring another cosine angle into this equation, which means we need to use the cosine law, right? The idea is to connect the point C with circumcenter and extend it, meet the circumcircle on the point D and connect AD, connect BD. So we know that angle DAC equals to angle DBC equals to 90 degrees because CD is a diameter, right? Which means AD equals to 2r times cosine B, right? Because this angle equals to B. 2r times the cosine angle ADC. That's the length of AD. So we can write as 2r times cosine B. And for the BD, it equals to 2r times cosine angle BDC, which is angle BAC. So that is cosine A, right? And then we can use the cosine law for AB. AB squared equals to C squared equals to AD squared plus BD squared minus 2AD times BD times cosine angle ADB. And AD squared, which can be represented for 4r squared times cosine squared B. And BD squared is 4r squared cosine squared A. So here we have minus 2 times AD times BD, which is 8r squared cosine A cosine B times cosine angle ADB, cosine angle ADB, because angle ADB plus angle C equals to 180 degrees, so cosine angle ADB equals to minus cosine angle C, which means here we can change the sign here and write cosine C here. Now we can see we actually find this term, right? We just need to reform it, which means 4r squared times cosine squared B, it can be rewritten as 4r squared minus 4r squared times sine squared B, which means C squared equals to 4r squared minus B squared, right? Plus 4r squared minus A squared plus 8r squared cosine A cosine B cosine C, right? That means if we use this one, which is minus 4r squared cosine A cosine B cosine C, it equals to 4r squared minus A squared plus B squared plus C squared divided by 2. Okay, so we now know this term, right? And we know it equals to 4r squared minus this one. So we can reform the first term into this format, which means IH squared equals to 4r squared minus this one. It can be rewritten as 4r squared minus a squared plus b squared plus c squared divided by 2, right? And plus a squared plus b squared plus c squared divided by 2 minus these terms, right? We keep it here. So for first one, it equals to minus 4r squared cosine a cosine b cosine c. And for the rest part, it can be rewritten as 2 times a plus b plus c, a squared plus b squared plus c squared times a plus b plus c minus twice of a to the power 3, b to the power 3, c to the power 3, and a, b, c. Right? So if you compare this term, this one, and this one, you can see we just need to prove this term equals to 2r squared, right? Now let's just calculate the denominator of the last term. So we have a squared plus b squared times a plus b plus c minus twice of this one, right? And notice that a squared, a to the power 3, we only have one term here, and we have minus 2 here, so we got minus to the power 3 minus b to the power 3 minus. So that's just because they are all can be rotary notated, right? So we can get this one term, and we minus 2abc, because for the first production we don't have abc there. We can just write it down here, and that's for all of the minus sign. So we just keep the rest part of the first production, which has ab squared plus ac squared plus ba squared plus bc squared plus ca squared plus cb squared, right? Now we want to reduce this one, and just look at this. We can extract c out, right? Make it a minus b squared, right? And for the a to the power 3, we can just have ab squared here, right? So make it to be, let's see, plus a b squared minus a squared, right? And for the ba squared and this one, so we can minus b squared minus a squared, right? And for the rest part, we have minus or plus c squared a plus b minus c, right? That's these three terms. Okay, for now we have this one here, so we can have c times a minus b squared plus a minus b, and this one is b minus a plus b, right? Plus c squared a plus b minus c. So this one equals to a minus b squared, right? We extract this out, and c minus a plus b plus c squared a plus b minus c, right? That means we can reform it as this one as a plus b minus c times c squared minus a minus b squared, which equals to a plus b minus c times C minus A plus B, C plus A minus B, right? So this can be rewritten as twice of P minus A for this one, and times twice of P minus B for this one, times twice of P minus C for the first term, divided by this one, that's 4P, right? So it equals to 2P times P minus A, P minus B, P minus C, right? I just times P on the denominator and numerator, so we can see it equals to, this is S squared, right? So 2S squared, 2P squared equals to twice of S2P squared, which is 2R squared. Okay, so we got 2R squared here. And we have minus 4R squared cosine A, cosine B, cosine C here. We combine these two terms, we get this one. Okay, thanks again for the for Andy's solution here, and we eventually make a supplementary video for the correlation of triangle centers. I hope you like this video. See you in next one. Thank you.